let's go through homework day 1. Okay, you should have tried this on your own first, and you're looking at this to check. I'm going to go through the first part, naming the chemical formulas and stuff quickly. Antimony tribromide, SBBr3, hexaboron monosilicide, B6Si, chlorine dioxide, ClO2, silicon tetraiodide, SaI4, iodine pentafluoride, IF5, dinitrogen trioxide, N2O3, ammonia, NH3, phosphorus triiodide, not PO3, P, not B, PI3. The names of these guys over here, tetraphosphorus pentasulfur, just oxygen, not dioxygen, not dioxide, just oxygen. Selenium hexafluoride, sulfur tetrachloride, disilicon hexabromide, carbon dioxide, diboron silicide, nitrogen trifluoride. Balance the following chemical equations and what type are they? So I always do my H's last, check out my N's first. I need a 2 here to balance my N's. Then I need a 3 here to balance my H's. 1, 3, 2. Two things combined to form one thing is called a synthesis reaction. Synthesis means coming together. We have KClO3 gives you KCl and O2. K's are balanced, Cl's are balanced, O's are not. We have 2 O's and 3 O's. Whenever we see 2 and 3 like that, we got to get a 6. So we do 3 and 2. Now we got 2 K's, 1 K, we need a 2 here. Balanced. One thing breaking apart is decomposition. Next one, NaCl F2 gives us NaF and Cl2. NAs are balanced. Cl's are not balanced. We need 2 of these guys. Now, NAs are not balanced. We need 2 of these guys. NAs are balanced. Cl's are balanced. F's are balanced. 2, 1, 2, 1. Type, this is single replacement. This F was a single guy. We had a pair here. The F kicked the chlorine out and took the Na for himself. So that's a single replacement. H2 plus O2 gives us H2O. H's are balanced, O's are not. We need a 2 here. Then we're going to need a 2 here and 1. And this is a synthesis reaction. 2 things coming together to 1. PbOH2 HCl. So this is the base. This is an acid. It's a base because it has OH in it at the end. It's an acid because it has H at the start. H2O, PbCl2. Now in this one, we rewrite our H2O as HOH, like this. That'll help us balance it. So PBs are balanced. OHs are not balanced, so we need a 2 here. OHs are now balanced. H's are not balanced. 1H, 1H. We need a 2 here. Now H's are balanced. Cl's are balanced. All right, let's check again. PBs are balanced, 1 each. 2 OHs, 2 OHs, 2 H's, 2 H's, 2 Cl's, 2 Cl's. So 1, 2, 2, 1. This is an acid base. Or double replacement. Acid-base reactions are just a specific type of double replacement reaction. Last one, AlBr, K2SO4. Now we treat this SO4 on this side as one entity because we have SO4s on that side. 1 Al, 2 Als, put a 2 here. 6 Brs, 1 Br, put a 6 here. So 2 Als, 2 Als, 6 Brs, 6 Brs. 2 Ks, 6 Ks, we put a 3 here. 2 Ks, now we've got 3 SO4s. We have 3 SO4s. Everything's a balance, 2, 3, 6, 1. Now the Al was with the Br and the K2 was with the SO4. The Al and the K2 switched. The K went to the Br. This is a double replacement. All right. Last one. Draw a Lewis dot diagram for these. Oxygen. Okay, so we start out. Oxygen has an O. And oxygen normally has 8 electrons. Ooh, that's way up high. 8 electrons. 2 in the first shell, 6 in the valence shell. 6 electrons in the valence shell. This oxygen has 6 electrons in the valence shell. These guys want 8 electrons in the valence shell. So this oxygen is going to need to borrow 2 from this guy. And this oxygen is going to need to borrow 2 from that guy. So I'm going to draw them separate. Here's one O. And here's my purple O. So my green O borrows 2 electrons from the purple O. The green borrows 2. The green lends 2 to the purple O. Then the green has 4 more. There's 4 more here. 1, 2, 3, 4. So this green guy now has 8 electrons. The purple guy also has 8 electrons. 2 of them are there's 2 bonding pairs of electrons. So it should look like this. OO, 1, 2, 3, 4. 1, 2, 1, 2, lone pair, lone pair, lone pair. Okay, so you have to work out how this works. Takes practice. N, H, H, H. N, nitrogen has 7 electrons normally. That means 5 in the valence shell. 5 electrons in the valence shell. Each hydrogen has 1 electron in the valence shell. Okay, so our nitrogen guy wants 3 more electrons. So he's going to have to borrow these 3 electrons. Each hydrogen wants 1 more electron. So this hydrogen will borrow an electron, this hydrogen will borrow an electron, this hydrogen will borrow an electron. So the hydrogens will borrow 3 electrons from the nitrogen. The nitrogen will then have 2 electrons left over. So we put our nitrogen in the middle. And 3 hydrogens around them. So the pink hydrogen will share an electron with the nitrogen. The red hydrogen will share its electron with the nitrogen. The purple hydrogen will share its electron with the nitrogen. Now the nitrogen will share an electron with the purple hydrogen. Now the hydrogen's valence shell is filled up because hydrogen only wants 2 electrons in its valence shell. Hydrogen and helium only want 2 electrons in their valence shell. It'll share an electron with there, and then we'll have a lone pair over here. So that's what it will look like. All right, so that's day 1 of homework. Lewis dot diagrams will not be on a test or a quiz. However, when you do Chem 30, they will be on tests, quizzes, and the final exam. So learn them a little bit now. We'll work on them later. All right, thank you for watching.